So the leftover part, that is the graphical solution to the uh, function having two variables. Okay, so this is the simple first 6 line codes for the solution of the graphical solution to the function having two variables. Okay, so let me run it. Live editor, run. So I have to put the equation here. So the equation was function was x to the power 3 into y square into x plus y minus 6. So this was the function. Let me run it. Okay. Yeah. Okay. We have obtained two graphs. Okay. Now we will look into one by one. Okay. We will look first one graph and then another. So let me zoom in out the first graph. Okay. So let me rotate it. So the graph looks like this. And if we check it from there, from right side, so so what we can find? So we can find only a minimum point is there. Can you say this is the minimum point? Okay, we can find this point as the minimum point. Okay, this point as the minimum point. Okay, so from graph we can say that how many minimum point or maximum point is there. From this graph we can find that part. Okay, now we will find the exact location or the exact point to this. Okay, so let me uh, so from this graph we will actually find the actual position. So to find the actual So to find the actual position of the minima, we have to find the eye of the we have to find the eye of this graph. Okay. So where we can find the eye of this graph? Let me zoom in out. Yep. So from here we have only one. So where is the eye of this? Let me check it. Let me zoom in out. No, there is no eye. Wait, that is around 3 comma 2 now. So this is 3 and this is 2. So here must be okay. So let us zoom it out here. Okay. This check. We have find the eye of this graph. This is the eye of the graph. Okay. So now this center is actually the center of this. The center of this is the minimum point. Okay. So wait. Okay. We can find the approximate values. Okay. So it is around 3.1 comma 1.9. Let me check it out. This is around 3. So take a round figure 3 comma no. So let us take 3 comma 2 as a round figure because we have to sum it up. Means we have to sum 3 or 4 points. We have to take the average. Okay, then we can get the actual value. So like this we can find the means this is the approximate minimum value. Okay, so this is the approximate minimum value that we can find out from graphically. Got it? So what is the answer in let us check what is the answer in uh, given. So the answer is the minimum of the function is 3 comma 2. So this is the actual solution. So this is the actual solution, the big solution with a big answer. So this is the actual solution. So from here we can find the average or the approximate value of that part. Okay, so I have left over this, and I have to uh, give you another that. Okay, that Simulink part. Okay, that haven't worked. Yeah, that sine wave that I have not cleared that part. Okay, so create a model. So let us go to library, Simulink, sources, then sine wave. Yep, another sine wave. So let us take amplitude to be 5, frequency to be 3. Apply, okay. Let us take amplitude to be 10 and frequency to be 2. Apply, okay. Now we have to go to the sinks and we have to take a scope here. Okay, a scope here. Got it. And another scope here. We will take a continuous and then go for some. Where is some? Sum and sum. So here is the sum. So what am I going to do here? I am going nothing, but I will check the amplitudes in through the scopes, okay? And I will further do this and do this. Now I will run the simulator and I will find the output here. So see, find there. The that is not a good graph, okay? And here another scope. So scope one and scope. So check this out. So this is for the first one. That is where we have put our amplitude to be 5, okay, and frequency to be 3, and here amplitude to be 10 and frequency to be 3, sorry 2. So check it here. So this is the graph is not pure, so the effect will be here also. In scope 2, find this is not a proper graph. So to get a proper graph, go to modeling, then go to model system settings, and then model settings. Under model settings, go to solver and expand this solver details. Now in max setup auto, you have to put a value of 0.01. Okay, now apply the changes and okay. Now again simulate it, again run it. Now check the, so it has become smooth. Why this is so? Because, okay, sorry, see, all the graphs have been smoothened. So this is our actual ladder graph. So if I expand it and how to, okay, scale y-axis limits, cursor measurement, no, not so. So let us make it scope simulation. Okay. So this is the simulating thing. Okay. So this is the actual graph. Got it. Thank you. That's all.